Hi everyone, in this video we're going to take a look at how to create a scene a bit like this. It's just a load of trees distributed, scattered on a plane, and then we're using the new world node, new in 2017 update 3, using the new world node to scatter groups of objects around our trees. So we've got these clumps of grass, we've got the mushrooms, and we've got just two types of mushrooms. As we can see if we move over the top here, the clusters are around the trees. So that's what the world node does. Well, the world node has two modes. One of the modes is all about clusters, and the other one's all about terrestrial ecosystems. We won't touch that in this video. If you're interested in that, go and find a different video. So this video is just going to look at clusters. The idea behind clusters is that they create non-overlapping points. However, your mileage may vary depending on the kind of settings you have and the model sizes you have and then the number of collision iterations that you set and all that kind of thing. So there's a few things to play with there. But the idea is you just very quickly get these layers of detail and layers of complexity added to your models very, very, very easily, as is the MASH way. So first of all, I'm going to give you a little crash course in what the world node cluster modes do before we go in and we create this scene. It won't take long at all. So I'll just start a new scene here. I'm going to create a sphere, and I'm just going to make sure that my MASH network is set to geometry type instancer, just for speed purposes here. And then let's just create a new network with, say, 5 points, and then if we just go right ahead and create a world node, we see immediately is that we have clusters of points created around our original MASH points. So you can see what I mean by that by me just increasing the point count here. So they jostle around as they try to not intersect each other. We've got collision iterations down here, which will control the quality of that collision. And we can have random point counts per collision as well. We've got a random seed down here. So we can have a minimum number, and then you can add some random points on top of that if you want to. So we also have a radius, which is the scale of the cluster points, and we have a radius variance on that, which is a plus or minus on the radius. So it's just a plus, I think, actually. And then we have this minimum separation, which is the separation distance between the objects. As you can see, they kind of move further away from each other as we increase this minimum separation. So that's the separation distance. Once that's reached, we'll stop running the collision iteration. So that's how that works. So if we just increase the point cluster, what we can do is we can kill the original points. So you can see that we had, if I just zoom into this cluster here, if I had keep turned on, we have the original point here, and then if we can kill it and avoid it, and so this means that the original points will now kind of collapse in to where they were. So we've got several modes here. We've got the sphere, which really I think should technically be called a ball, but it's effectively, if I just turn off the variance here, the radius variance here, what we're trying to do is all the points are effectively trying to get to the center of the where the original MASH point was, so the center of the cluster. So there are several cluster modes. We've got this disk mode as well, which is if I shrink down the radius here and then increase this, you'll see that we've got they're all trying to they're all kind of in a disk now instead of in a sphere. And just increase the collision iterations there, and you can see that we've resolved some of the intersections. And again, they're all trying to get to the center of the cluster, but they are they're in 2 dimensions this time instead of a sphere. And then we have a circle, which you can see like this. So if I reduce the cluster radius here, you can see that as they increase. Also note that the clusters intersect with each other as well. So you can see as they pass through each other, they're trying to avoid each other, and then we can just shrink that down, and it's something very like disk. So let's just increase this back up or whatever. So that's so you can end up with some very interesting distributions very, very quickly. And so that's circle. We've got a Fibonacci spiral, and to show this off, I'm going to have to shrink the radius down, and if I just set this to 0 and turn the cluster radius right down, really quite low, so something like this. Increase the number of points, and we end up with a Fibonacci distribution. Oops, what's going on here? So end up with a Fibonacci distribution, there you go. And we do the same thing with a sphere as well. So something that's worth noting is that the Fibonacci sphere is just the shell of the sphere. So if I increase the radius on these slightly, again, just notice that once they get to a certain size, they'll collide with each other, and the different clusters will collide with each other as well. You can actually, if we go into the middle of this is hollow in here, and that's the difference between the Fibonacci sphere and the sphere, because the sphere, this is packed in the center here, so it's like sphere packing going on. So they're all trying to get to the middle. There you go. So it's nice and dense. Right. So anything else in here? Map based. I'll show you that later. Different thing. Different video. Okay. So now that we know what's going on there, let's get into our start scene. And yeah, so here's our tree, and let's grab that and create a new mesh network. So let's do that. So here's our new mesh network, and I'm just going to roll down the mesh settings here and then drag our ground onto the input mesh, which is going to kick us into the mesh distribution mode automatically, and then we can choose a different random seed here just to get a different kind of distribution. Find one that we like, something like this. It's not really important. In an ideal world, I'd want them all to be away from the edges, just because you'll see why in a minute. But we can always use a piece of proxy geometry for the distribution, and then a different piece of geometry for the on the world node. You'll see the advantages of that. If I now add a world node, you'll see that all of these trees appear, and that's because the tree is the only object in the mesh network, and so a cluster of trees has been created around a tree in the same way that the sphere was being created around the spheres in that little demo I did before. So what this tells us is we need to go onto our instance here and add some more objects. So I've got 3 mushrooms, and I've got this clump of grass. So if I add select the instance here, I can just go add selection, which has given us IDs 1, 2, 3 of mushrooms and then 4 of grass. So what I can do in the world node here is just set the fixed ID to something like 1, and then that you can see that adds our mushrooms there. So our mushrooms are kind of hovering in the air, and the scale is all a little bit wrong, and that's because the world nodes collisions are based on the objects having a 1 unit size when they go into the mesh network. Because you can always increase the scale with mesh, so you could set the scale with an offset node and all that kind of thing, or you can set the scales entirely using the radius sliders here. So that's a kind of assumption made, but there is a cheat, and I'll show you that now, and that's just increasing this minimum separation distance. So if I do that, then the objects will kind of resolve their intersections just because of the increased minimum separation distance. And you can do that by eye, so it's kind of easier than going through the setup process of scaling everything down to one world unit, putting it in the mesh network, and then letting the world node be in complete control of the scaling. So it's just easier to do it with the minimum separation distance here. Right, so they're hovering in the air, we want them to snap to the mesh. So we've got this input mesh down here, so let's grab our ground again, and this is where you could use a different piece of geometry. So you can add the ground and go input mesh here. So the reason that I would kind of, it might be desired to use a piece of proxy geometry for this is because at the edges here, you end up with the mushrooms kind of like bunched up on the edge as they are not allowed to leave the mesh. So that's kind of a downside of using a piece of geometry when you have objects at the edge. So what we could do actually is we could just duplicate this and increase the scale of it slightly, and then use this ground 1 with the world node. So if I just drag ground 1 over input mesh, then that solves that problem there, and I'll just turn off ground. So that does that. Now we can change our cluster mode. So we want to avoid our original object, and we want to have a large separation distance and probably increase the quality of the collisions somewhat. And let's say we probably want something probably more like the circle, right, as a distribution. So if I maybe something, I don't know, let's just start playing with the settings. I can't remember what I did last time, so let's add some radius variance so we have some random scales on these things, and then we can reduce this somewhat and see what happens. So well, let's try something. Actually, let's go back to the sphere, and then let's just increase the separation distance so that we get the original mushrooms well away from the original tree, right? So something like that. And so we've ended up with these kind of distribution to begin with. Okay, I'm happy with that. And what we can do now is just do the same thing. So over in the mesh editor here, well, we could just add another world node. So if we add another world node here, we end up with the same problem. So we just change the fixed ID to 2. And what you're going to have to do is you'd have to drag in the ground mesh again and change the clusters, whatever. We want to keep and avoid the previous points and increase the separation distance and probably increase the quality of the collisions a little bit. So yeah, this is what we can. Yeah, this is kind of what you end up with. I mean, again, the because we've added a second world node, we end up adding a cluster point to every other point that's going. So you can end up with, if I just change the random seeds here a little bit, if you have the, just remember that you're going to be adding a cluster to every single mushroom as well as the original tree here. But that's fine for what we're doing. So let's just add a little bit of random scale here. Maybe just make these mushrooms smaller slightly. And then in the mesh editor here, we can grab this first world node, and we can, if we just grab it so that we're moving, and we can see the white bar here. If we now hold down Alt and then let go with the node at the top of the mesh editor here, you can duplicate that node. Something as you like. It will not duplicate the input connections here, so you need to drag on the ground again. But now, if we just change the fixed ID to 3, you can see that we're getting our third mushroom type. Let's repeat the trick. So let's grab our world node 1 and then hold down Alt, let go at the top here. We get another one. We can change this fixed ID to, whoops, I'm playing with random seed. 3, 4 to get our grass. And then we can up the radius. The grass is bigger, isn't it? Oh, we need an input mesh, of course. So that would be the ground 1. And probably want radius variance on the grass rather than anything else. And so very quickly we've recreated our original scene. So the one thing that we don't have here, of course, is all our rotations are the same. So let's just add a random node and take 360 the rotation, and we're done. So that's it really, just a very quick walkthrough of the kinds of things you can do with the clusters, and this is just an example use of it with the trees and the mushrooms and things here. Yeah, so just have an experiment, and that's kind of the idea behind the world node in this cluster mode, just to quickly add layers of complexity and all that kind of thing to a scene. I can just turn off our original models here because we don't need those in the viewport. So that's refreshed it, and now we've got some shadows. So yeah, so that's kind of it really. For the cluster mode demo, and I'll come back and do a video on the ecosystems shortly. Hopefully you found that useful, and hopefully you'll find the feature useful. So let us know what you think. Thank you very much.